Here I'm continuing the problem set brought to me by a student, and I have 25 and 29 I'm going to look at. So 25 says 0.5 sine cubed x equals 0.1 sine x. So in doing this, I didn't do a substitution. I just jumped right in and did it this way. I brought this 0.1 sine x over to the left side, so I'm going to subtract 0.1 sine x minus 0.1 sine x. And then I have 0.05 sine cubed x minus 0.1 sine x equals 0. And just to clear out the fractions, or the decimals, I'm just going to divide by 0.05 every term. And I'd have sine cubed x minus 2 sine x equals 0. And then I can factor out a sine x times, then I have a sine squared x minus 2 equals 0. And I have, again, a product that equals 0, so use the zero product property. Sine x equals 0, so x would be, and this one they give us the constraint that x has to be in the interval from 0 to 2 pi. So what works here would be 0 and pi. And for the other one, we have sine squared x minus 2 equals 0. So sine of x squared x would be 2, and sine of x would be plus or minus the square root of 2. That means we're trying to find a value of x such as sine of that value is going to make the square root of 2 or negative square root of 2, and that doesn't happen, so there's no solution there. So our solution is 0, pi. And I thought that I'm reading the instructions, it says it's 2 pi as well. I think the answer key showed, it says 0 to 2 pi with a parenthesis. So I don't think we include the 2 pi, but if the book did, it's because it's not following what it said there. But okay, I feel like that said 2 pi in the answers on the answer key. Moving on to 29, we have secant squared x minus 2 plus 8 tangent x equals 42. So in doing a problem like this, it's really important to be fairly familiar with these identities. And when I'm saying, I mean, there's a bunch of them out there, and I realize it. And this one harkens to the Pythagorean identities. So just the fact that secant squared x is here and there's a tangent there, knowing that secant squared x and tangent squared x are related with the Pythagorean identities, that's a good thing to know, so you can go back and actually look up the identity if you don't remember it. But the identity says this. It says secant squared x minus 1. So I'm just breaking that out, so I have a secant squared x minus 1 is equal to a tangent squared x. I don't know why that popped up. And then so the reason I have this minus 1 over here is because minus 1 and minus 1 is minus 2. Plus 8 tangent x minus 42 equals 0. So I brought the minus 42 over. Now let's see. This is going to be a tangent squared x. And then minus 1 and minus 42 is minus 43. So plus 8 tangent x minus 43 equals 0. So then I'm going to go back and use my substitution because this one's not so obvious unless you're really comfortable doing the quadratic formula, because this is not going to factor, but doing the quadratic formula with the tangent in there. I'm going to go ahead and call this u equals tangent x. I mean, you can do it that way. I'm going to do it the u way, the u substitution. So u squared plus 8u minus 43 equals 0. So u is going to be equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 43 all over 2 times 1. So that's negative 8 plus or minus the square root of, and I just did this in my calculator, 236 over 2. So u equals negative 8 plus or minus, And 236 can be factored to where it's 2 times the square root of 59. So you can factor 4 out. The square root of 4 is 2. I think at this point in your math maturity, you can handle that. And this reduces down to become -4 plus or minus the square root of 59. Now at this point, a lot of people will be saying, whew, I'm done. But we're not done. We're close. But we have to think again, what was u? U was, sounds like bad grammar, tangent of x. So tangent of x equals -4 plus the square root of 59, or tangent of x equals -4 minus the square root of 59. So x equals tangent inverse of -4 plus the square root of 59, or tangent of x, now it's solving for x. X equals tangent inverse, or arctangent, of -4 minus the square root of 59. And those are the answers that we're after. So I hope that helps.